Hello and welcome everyone. This is Iftekhar Ahmed and my today's talk is about on the relationship between design discussions and design quality, a case study of Apache projects. This is a joint work between Oregon State University and University of California, Irvine. Ensuring good design quality is important since it's the key to ensuring the performance, robustness, and maintainability of software. And developers need to not only be aware of the design of the system, but also about the underlying design decisions, because changes made by developers unaware of the design decisions has impact on overall design quality, which can impact bug density, fault proneness, developer productivity, maintenance, etc., as shown in prior research. Managing design quality is a challenge because in order to ensure design quality documentation is mandatory, which we already know is rarely maintained. Moreover, design decisions made during the software lifecycle are typically not well documented, and so the rationale for these choices are often lost. In OSS, this is even a bigger challenge because design-related discussions among developers are the only form of design documentation that developers can use to coordinate and build together. In many cases, design discussions work as the design documentation, and it is challenging for developers to find those design decisions from the archived discussions later and work accordingly. Failure to maintain the design in response to the frequent software changes leads to decay in the software design and the growth of technical debt. As a result, code becomes more difficult to understand, and this forms a vicious cycle of design degradation, further negatively impacting the quality of the software. Prior work in this area has looked into how design discussions are embedded in pull request comments and detecting design discussions from a single channel using machine learning technique. However, there are gaps in the understanding related to how design discussions are conducted and what is the relation between design discussions and design quality. To be specific, we also wanted to understand what channels are used for design discussions, who are the participants, and how these decisions are implemented, and how design discussions help design quality. The research questions that we answered in this work were how are design-related discussions conducted in OSS projects, and what is the relationship between design discussions and design quality in OSS projects. Now I will talk about the steps of the empirical analysis that we conducted for this paper, which we started by selecting 37 Apache projects written in Java. We collected them from GitHub. We selected projects from Apache because they use multiple communication channels and have specific instructions for using these channels. Selecting random projects from GitHub without well-documented discussion procedure would make it difficult to ensure that we have identified all communication channels. Since our goal was to understand how discussions are scattered across all channels, identifying all channels is of the utmost importance. So we identified mailing list, Bugzilla and Zira as issue trackers, and pull request comments. In total, we identified 1.6 million discussions. The entire thread of interactions, which in case of emails was grouped by the subject header, and in case of comments, it was grouped by the issue ID, was the unit of analysis and considered as a discussion in our work. Since our goal was to identify the discussions that were related to design and we had to deal with a large volume of data, we could not do it manually. So we decided to rely on machine learning for this. And just like any machine learning pipeline, we started by building the machine automate training data. We manually labeled 5,000 discussions. Then we built and compared multiple models to identify the best classifier. We compared decision tree, logistic regression, support vector machine, and multinomial naive Bayes, and our results showed that decision tree outperformed the other classifiers by a large margin when compared based on AUC. So we decided to use decision tree for the classifying rest of the discussions in our dataset. Since one of our goals was to understand who are the contributors, who are the participants in these discussions, and also who are the implementers, for that we needed to classify or categorize the developers into core and non-core developers. So we consider a core developer as core if the developer is among the top 20% of the developers in that project, which was calculated by the number of commits they authored. Otherwise, they were placed in the non-core category. We also wanted to understand the relationship between design discussion and design quality, and for that purpose, we used code smell as a proxy for measuring design quality, which has been used as a design quality measurement in prior many other work. So code smell was initially developed to identify future maintainability problems. It's neither syntax error nor compiler warning. It's essentially a symptom of poor design or implementation choice. One example of code smell is God class, which tends to concentrate functionality from several unrelated classes. And there is a large catalog of code smells that exists in prior research. Since our goal was to understand how design discussions and design quality interact and what are the perception of real world developers regarding them, we also, apart from the mining study, we also conducted a survey. We identified participants by identifying the unique email addresses from the projects that we were analyzing. We randomly selected 2,000 participants from 7,682 developers. We asked them how they conduct design-related discussions in OSS projects and what are the problems they faced while finding design-related discussions. We also asked the respondents to rate their difficulty level of finding design discussions in each of the communication channels they were using. In total, we received 110 responses out of the 2,000 emails that we sent out to the participants. So now we will talk about the findings of this study. When we were looking into the prevalence of design-related discussion, we found that though developers use multiple channels, mailing list is where the majority of discussions take place. 89.5% of the discussions in our dataset happen in developer mailing list, as you can see on the figure on the left side. When trying to understand the reason for this, we found that through manual inspection, that Apache has a culture of starting discussions in email, and upon agreement, moving to the issue tracking for implementation. Since email allows developers to have lengthier discussions, this might be another reason for email to be the most frequent channel used for design-related discussion. When we asked the survey participants, they reported that along with the documented channels, a large part of the discussion takes place in undocumented channels such as verbal meeting, personal email, etc. So design discussions occur via both documented and undocumented channels. One of our questions was to understand who are involved in design discussions. It is important to investigate this question because if design discussions in a project are controlled by a small core group of developers, it can leave out a large group of non-core contributors. By looking at the results from mining on the left side, at first glance, it seems that non-core groups are in the minority and unable to participate. But recall that by definition, non-core groups have fewer overall code contributions, which also translates to fewer instances of participation in discussions. So before checking if the difference of mean between these two groups are statistically significant or not, we normalize the number of design discussions by each group. So after normalizing, the mean of design discussions by core developer is 0.12, and mean design discussions of the non-core developer is 0.06. While the difference between these two groups are not statistically significant, according to Welch two-sample t-test, the effect size is also small, which is 0.30 measured using Cohen's d. Our results from the survey also indicate similar results, showing that both core and non-core developers participate in design discussions, with some difference in the amount of contributions between these two groups. Next, we wanted to understand who implements the changes resulting from design discussions. To investigate this, we first identified the assignee of each issue in the issue tracking system, which were Zira and Bugzilla. In the next step, we linked the assigned issues to the commits in GitHub. As shown on the left side figure, 67% of the were authored by core developers and 32% were authored by non-core developers. And 6% of the issues could not be linked due to missing link problem. To understand whether core developers are more involved in implementing design-related changes, we compared the mean number of design-related changes by core developers with that of non-core developers. The results show that two groups are significantly different and with a medium size effect, which is measured, which is 0.77 measured using Cohen's d. So in summary, our results from the survey also indicate similar results, showing that core developers are mostly responsible for implementing design discussions. Our next goal was to understand how do design discussions evolve. As projects mature, it may need fewer design discussions as the design is already stable. However, with the growth of the project, more new features added in the project, which require more detailed discussion to ensure that these added features are compatible. And in OSS project, as the project matures and gains visibility, more contributors join the project with fresh design ideas. For that, they need the understanding of the core design decisions, which can affect how design discussions occur in these projects. To see this evolution of design discussions in Apache project, we tracked the design discussions of each project over 560 weeks. Design discussions follow a decreasing trend and start to drop approximately after 250 weeks, as you can see on the figure shown on the screen. When comparing the individual projects, among 37 projects, we found three different trends. Decreasing trend shown in 56% of the projects. Maven is an example, which is shown on the left side. Constant trend was shown in 29% of the projects, and Log4j shows an example of such trend. An increasing trend was found in 13% of the project, and Project Ant shows an example of such trend. So distinct design discussions trends exist, but on an average, design discussions decrease over time. Our next question was about investigating the correlation between design discussions and design quality. In OSS, design discussions is only way to take care of design quality. Intuitively, projects that discuss their design regularly likely to have fewer design issues. As design discussions happen throughout the project's life, we want to see how that helps design quality. And we start by looking into the situation of design issues across projects per week. On the left side, you can see the number of design issues per week measured using code smells, which shows an increasing trend. Since design issue per week and code smell count per week both are time series data, we calculate cross correlation between them. 54% of the projects, which 21 out of 37, shows statistically significant cross correlation. Some of the reason for this weak correlation could be the hard to retrieve discussions because of fragmented discussion across channel and unofficial discussion. Lack of tool support to retrieve and tie discussions to their work is also maybe another reason for such weak correlation. We also saw that lags between two time series ranging from 1 to 22 weeks. Another reason could be that the developer attention is very low, low regarding these topics, since 79.23% of our survey respondents said that they do not check the impact of their contribution on design quality. So in summary, design discussions and design degradation are weakly correlated. Which brings us to the implication and future work of our work. Our results indicated that majority of design discussions occur over email, and part of them are lost due to the difficulty in finding them, and also due to their being fragmented, which opens up the opportunity to develop tools to identify a design discussion thread across multiple channels. Future research can also investigate the effectiveness of tagging design-related discussions and linking them to the pull request or to the part of code where the relevant implementations exist. Identifying design discussions could also help in automated review assignment, since current recommender systems for task assignment or code reviews use developers' expertise to identify the best match. Identifying individuals who have been involved in design discussions and therefore have a bigger picture of the intention of changes can prove beneficial for such recommender systems. Our results also showed that discussion happens in unofficial channels. Further investigation is required to have an understanding regarding what types of discussion occur over these unofficial channels, who participate in these discussions, and what is the impact of such discussions on the overall quality of the project. Thank you for watching the video, and if you have any questions, please send an email to the address shown on the screen.